Um, I'm Eric Salate, and I am in the Climate Impacts group here and in the Department of Atmospheric Sciences also. I mostly work on regional modeling of the climate and also using climate information to understand the impacts of climate change on the Pacific Northwest. These models have been developed over many generations of scientists, graduate students, and researchers developing them. It starts with basic physical equations, starting from Newton's second law, really, the movement of matter in the atmosphere, and then also transport of heat, so equations that relate to heat and energy, and all of these things come together in many different components. There's a land component that simulates what happens on the land surface, what happens in the atmosphere, what happens in the oceans, what happens with sea ice, and all these components then are brought together from multiple disciplines to create, a synthetic climate system model that we can use to project future changes. Most of the work right now is looking at extreme events in precipitation and temperature that we can model with the regional climate model that we're developing. It's the extreme events really that the impacts will be felt most strongly. The recent events, flooding events at Mount Rainier and Centralia in the past couple of years have really made people very concerned about the likelihood of this being related to climate change and seeing more of these events in the future. And right now it's very difficult to say that these events are related to climate change. There's certainly a good physical argument for why that would happen, but to actually confirm this and attribute these sorts of things to climate change has been much more difficult than you might think. It's a combination of using models and analyzing the observations to see that. So in a sense, we've kind of raised the concern that there might be more extreme events under climate change, but we haven't really proved it, and we haven't really quantified how much. And so the engineering community has kind of become aware of this, and they're ready to use this information. So that's really our biggest effort going forward now, is to try to give them kind of probabilistic information that engineers use for planning purposes. Yeah, so under the most likely impact of warming in the Pacific Northwest would be the reduction of the snowpack in the mountains during the wintertime, which means that most of the water will be flowing down the rivers in the fall, increasing the likelihood of flooding when we already have plenty of water, and reducing the amount of water coming down the streams in the spring and summer when we really need water for consumption, for salmon, and for hydropower generation. So it's sort of shifting it from when we need it to when we don't need it. So the University of Washington is probably one of the best universities for doing this kind of research because we have the expertise in atmospheric sciences and oceanography and land surface and hydrologic modeling. We have a climate impacts group here that I'm part of. And you really have to have this well-rounded expertise to bring all these disciplines together to study this problem, because it's not going to happen in one department or another department. The other thing is we really have a substantial amount of support from the state for doing this kind of work, and that's been critical.